Alright, so review video number 2, basically, or second period video. Tuesday, and we're going to do 2, 5, 8, 11, and so on. Right away, this table, remember there's the free response question on the test, has a table that looks a lot like this. Numbers changed, but with F and G and F prime and G prime, where we can ask all these types of questions. So this 1 through 7 here, this is pretty darn close to the free response question on the test. Alright, so number 2. Find h prime at 6 if h of x equals f times g. So what's the main rule we're looking at here? Product rule. So again, it doesn't matter how you get there. F prime g plus g prime f. Again, it's kind of hard to mess up the product rule because it's addition and multiplication. But I want that at x equals 6. So I go to my table, and I just need to be very careful here. F prime at 6. F prime at 6 is pi. G at 6. G at 6 is negative 7. G prime at 6. G prime at 6 is negative e. And f at 6 is negative 5. Okay, so who knows what kind of goofy function that is that pi's and e's are showing up, but negative 7 pi plus 5e. Negative 7 pi plus 5e. Oh, they did it. They've got it written backwards, but that's the same thing as d. Number 5. We're still doing the same thing, or the same table, so same information. H prime of x if h equals f of x minus 1. Okay, so h of x, this is kind of a chain rule thing, right? Like the outermost is f, so f prime at x minus 1. And what's the derivative of x minus 1? This is why I said it's kind of a chain. I guess I shouldn't say it's kind of. It's still a chain rule thing. It's just that the derivative is 1. As opposed to number 4, when you do the chain rule, you're going to have a times 2 at the end because of the 2x in there. So h prime at 10 means plug 10 in for x. So that's f prime of 10 minus 1. F prime at 9. So I just go look at my table. F prime at 9 is negative 9. So answer choice B. I have high hopes for the free response part of the test. But we'll see. Number 8. The graph of the function g on the right consists of 2 line segments. F is given by g of x. So clearly some chain rule things going on here. What is the value of f prime at 1/2? Okay, well let's find f prime first and then we'll worry about the at 1/2 part. Okay, outside in may be tricky because there are 2 g's there. So the outermost g prime, but then leave the inside stuff alone, times the derivative of the inside g, leave the inside stuff alone. And I guess if we really want to take it all the way, the derivative of x would just be 1. Good example of show your work to get partial credit on the multiple choice test. Like if you get that far, that's probably worth half, well, they're 3 points each. So that's worth 1 point for sure because you did the chain rule right. The rest isn't calculus, the rest is algebra. I guess there's still some calculus, because if I want G prime and I have a graph of G, well, let's back up, because the first thing I need is G of 1/2. G of 1/2 is 4. So G prime at 4 times G prime at 1/2. How do I find G prime from a graph of G? What am I looking at? Slope. So I want the slope at 4 times the slope at 1/2. Well, the slope at 4 is over here. So let's see, from 1,5 to 6,0. That's going down 5 over 5, so that slope's -1. The slope at 1/2, let's see, we went up 6 over 3, so that slope is 2, positive 2. So -1 times positive 2 is -2. Again, even on multiple choice, show your work, have it nice and labeled, because that's the main calculus idea right there. And then picking off the slope, that's a calculus thing too. Number 11. Find the slope of the line tangent to the graph. Okay, so that's fancy talk for y prime. For y equals e to the x log base 9 of 4x at the point 1/4, 0. Look, mouthful. So take a derivative, and then plug in 1/4. The derivative, though, is going to involve the product rule. So first times the derivative of the second, so that would be 1 over 4x times 4. And the base is an e, so where does natural log 9 go? Top or bottom? On the bottom. And you can see that's one of the things that's sort of reflected in the answer choices there, where it goes. Plus, so that was first times derivative of the second. Now I want second, log base 9 of 4x, times derivative of the first. Well, that's just e to the x. Okay, let's do maybe a little bit of cleanup before we even plug things in. Especially if I look at my answer choices and it looks like they're factoring out e to the 1/4. I'm going to factor out e to the x. Those 4 cancel. So 1 over x natural log 9 plus log base 9 of 4x. Alright. Again, I keep looking at my answer choices. It's maybe C or D, because that looks like it has the plus in there. Let's plug in 1/4 and see what happens. So add 1/4. E to the 1/4. Okay, that doesn't really tell me anything. We've all got that. 1 over. Okay, if I put 1/4 in the bottom, what happens to that, or what does that become? I don't want to take the time to write out, keep it, change, and flip it here. 1/4 in the bottom becomes a 4 in the top. So 4 over natural log 9. So that's looking like answer choice D here, maybe. Plus log base 9 of 4 times the 4th is 1. So that doesn't look exactly like D yet, or C. What's the log of 1? Think back to your the old loop-de-loop fishhook thingy. 9 to the what would give me 1? 0. So that's 0, which means it was not C or D after all, because one of those terms went away. So 4 e to the 1/4 over natural log 9. That would be answer choice B. 14. Cosecant. Ugh. Alright, out to the side before I even get into this problem. The derivative of secant is secant tangent, which means, again, I don't have cosecant memorized. I know that it's related to secant. Derivative of cosecant then would be negative cosecant cotangent. Okay, and that sort of makes sense. I see cosecants and cotangents in my answer. Alright, product rule. So first times derivative of the second. So e to the negative x. Derivative of the second would be negative cosecant 2x cotangent 2x times 2. Get the chain rule thing on there. I'm looking at my answer choices. I can't. There's too many 2's and cosecants. I don't know. I can't narrow it down yet. Plus the second one, cosecant of 2x, times the derivative of the first one, e to the negative x, times negative 1. Don't forget the chain rule off of that one. So it looks like, now I'm looking at my answer choices, they all have e to the negative x factored out and cosecant of 2x factored out. So let's take out e to the negative x and the negative and the cosecant of 2x and see what's left. So negative e to the negative x cosecant 2x. Alright, what's left from the first term is 2 cotangent 2x. And what's left from the second term is, well, it's nothing. We took it all. Now be careful. Surely no one's going to make the algebra mistake here. If we take it all, what do I need to put over here? Plus 1. Okay, so does one of these answer choices match 2 cotangent 2x plus 1? Answer choice D. Some calculus, some algebra on that one. Number 17. F of 3 is 7. The derivative of f is 1/2. The function h is given by this thing. Find h prime at 3. Well, let's find the derivative of h. What rule's going on here? Natural log of f of x. Chain rule. So I'll need to take care of the natural log, and then I'll need to take care of f, and I guess I need to take care of x, but that'll just be 1. So derivative of natural log is 1 over the argument times the derivative of the argument. So now we're getting into the chain rule. The derivative of f is f prime, and the derivative of x is 1. So we really want to go all out with showing our chain rule there. So this really isn't too bad. F prime over f. And if we evaluate that at 3, f prime at 3 is 1/2. F of 3 is 7. That's a safe stop. It's also 1/14, but it's a free response question, so don't mess up the fractions if you don't have to. Number 20. Oh, by the way, you can omit number 19. 19 uses a rule that we haven't covered yet. It's kind of a standalone rule. It's not hard. We just haven't done it yet. And there's not any on the test that are like 19. So don't worry about it. Just throw it away and don't even worry about it. Number 20. Let f be the function given by this thing. What is the value of f prime of 0? So take a derivative, plug in 0. And this looks like straightforward. Like what's the catch here? This looks easier than most of the ones we've done so far. Derivative of cosine is, what's the derivative of cosine? Negative sine. So negative 2 sine of x. The derivative of e to the x is e to the x. And then if we plug in 0, negative 2 sine of 0 plus 3e to the 0. Okay, this may be more of an algebra trig issue than a calculus issue. What's the sine of 0? 0. And what's e to the 0? 1. So all that to just get 3. Another great place to get some partial credit, right? Show me what the derivative is. You've shown me you know the calculus. Hopefully you don't mess it up from there, but if you do, I can give you some partial credit because you at least showed me the calculus. I would need to see f prime equals. Don't just put this because you haven't communicated what that is. Now, if you're confident you're going to get the answer right, and so you're just jotting down the derivative and plugging things in, fine. But if you mess something up, I can't give you partial credit if I don't know what that is. Last one, 23. Y equals e to the nx, where n is a positive non-zero constant. Then the nth derivative is, okay, I don't know what this is, but let's find a first derivative and a second derivative and maybe a third derivative. And see if the pattern shows up here. So first derivative would be e to the nx times n. Chain rule, that n drops down. Second derivative. So this n is still there, and then the derivative of e to the nx is e to the nx times n. So that's n squared e to the nx. Maybe you can see what's happening. Maybe we need to go one more. Third derivative. So I've got the n squared sitting there. The derivative of e to the nx is e to the nx, and then chain rule gives me another n. So n cubed e to the nx. So it looks like the power of n is whatever the derivative is, right? Like the second derivative, we've got n squared. The third derivative, we've got n cubed. I think that's enough to see the pattern. So I need e to the nx. So yeah, e's out. And then I need n to the whatever derivative we have. So it's not factorial. It's not just one n. It's not squared. It's n to the n. However many derivatives we have, what the n is. Right, so that's the middle third of the section of the review worksheet.